picking up where we left off, this is going to be the third video in the series of how to create multiple gills along, what we started with as a single object, and we went into having multiple gills. And now what we're going to do is based off, multiple gills is based off of two curves. Now we're going to take the object as a surface, break it down into its boundary curves, and apply a similar concept to the last video here. To do that, let's take our field gills definition and copy paste it, like so. And we're going to go ahead and change this as a surface gill title. There we go. And then what we're going to do is go ahead and turn off all the previous data. So sweep, right-click, view off, and there we go. Now what we want to do is, within the definition, we need to start with the surface. So instead of starting here with the two original long curves, let's go ahead and drag these over just a bit. I'll drag it towards the end. I want to start with the surface. So I'm going to go ahead and go to Parameters, Geometry, and I can use a surface or B-rep. Either one of those is fine. I'm going to call this my base surface. Set one surface and click on there. Now it's referencing to Grasshopper. Now the first thing we need to do is extract all the boundary edges of this. Okay, so to do that, we're going to use our surface, we're going to analyze it, and we're going to go ahead and do B-rep wireframe, and it extracts the wireframe curve edges of a B-rep. Go ahead and drop that in. Run that into my B input, which is the B-rep I want to test. And you'll see the result of that is 4 line-like curves. These are the 4 edges that make the object up. I'm going to go ahead and just right-click, turn my preview off. And I'm actually going to even hide the rhino geometry. And there's my 4 edges. That's the wireframe edge that makes up that surface. Now what we want to do is we want to find which one is the bottom and which one's the top, and isolate those two. To do that, anytime we want to isolate one item out of a list, we're going to use a list item component. So you go to Sets, List, List Item. You're going to use this component all the time. And the list of data we want to sort through is all of the curves. So that's all these wireframe curves. And the eye is set for 0 right away. So if I select it, you'll see this bottom edge becomes green. Perfect. That's what I know I want. I'm going to go ahead and copy and paste this. And we're going to go ahead and do this a second time. Now, from what we learned today in class, we know that if the bottom edge is 0 and this object is moving in a counterclockwise direction, the right edge should be 1, the top should be 2, and the left edge should be 3. That means the starting point's here in the corner, 1, 2, 0, 1, 2, and 3. So if we have 0 here, we also want to pick up the number 2 item. So what I'm going to do is go to Parameters. I'm going to put a value of 2 stored into a panel tool. I'm going to go ahead and wire that into the I input of the list item. Sure enough, now with this one selected, we can see that the top one is the selected one. So I'll see that better if I turn off the B-rep wireframes. And there we go. The bottom one is the 0, and the top one is the 2 index item. Perfect. Now, I could try to feed these straight into curve A and curve B, like so. But you'll see what the result is what I call the bow tie issue here. Okay. The reason what's happening is because of that curve direction, the first curve is traveling from left to right, the second curve is from bottom to top, then the third curve is going from right to left. So on the 0 curve, the left is the start. On the 2 curve, the right is the start. Therefore, it's trying to loft from start to start, end to end, and you get the bow tie kind of effect. What we need to do is flip one of the 2 curve directions. Doesn't matter which one, we just need to do one or the other. If we want to keep counting from left to right, we'll flip the 0-2 curve so that it is also traveling from left to right. To do that, let's go to Curve, Utility, and we simply flip the curve. It's the second one down on the left. Again, we only want to flip one of these. We're going to flip the second one. So after the list item, I'm going to go ahead and flip its direction and replace that with the curve. And there we go. So now we can go ahead and show the original surface. You can go ahead and see how the original surface is subdivided now into a bunch of panels, as I hide that are then controlled by a rotation angle as well as a scale factor. Okay. Let's go ahead and organize this a little bit. Again, we're going to go ahead and just kind of group similar items. Throw that panel tool in with that group. And we'll just group these first 2 just for the sake of grouping things. And sort these things down a little bit like so. All right, The last thing we want to do is introduce an attractor curve, and we want to use an attractor curve to, say, control the rotation angle. So we're going to focus here in the middle where the rotation angle is happening. So let's give ourselves a little bit more room. There we go. And instead of a slider controlling the rotation, we want to use the distance from an attractor object. Well, the first thing we need to do is have an attractor object in our screen. So let's go ahead and drop in a point, like so. I'm going to drop in a point container into Grasshopper. So go to Parameters, Geometry, Point. I'm going to go ahead and right-click, change this to my attractor point, ATT-PT. Set one point, and click on it like so. Now, in the previous example, the Eisman project, we measured the distance from this attractor point to the entire grid of points. Here we don't have a grid of points. But what we could do is we could say that these midpoints kind of are sample points or representational points for each of these fins. Those midpoints are the middle of curve C. That's this component right here. So we can measure the distance from these midpoints to the attractor point and somehow reapply that as a rotation angle. To do that, let's go underneath our vector, point, and distance. Measure the distance from the middle of those curve C's to the attractor object. And the distances we get should be within a similar range. Okay? So we get things that are between, looks like 104 all the way up to 135. That's going to essentially become our scale reference within it. Okay? We want 104 to be the lower limit, 135 to be the upper limit. We want to convert that to, say, 0 to 90 degrees, or negative 90 to positive, something along that lines. This is where we do that whole remapping numbers. So what we're going to do, again, bring this down a little bit. We're going to use those distances. We're going to go to Math, Domain, and Remap Numbers. Now, the values we want to remap are the distances. The target domain is our rotation angle. So what we want to do is, first off, I'm going to remove it from this group. So let's just delete this group. I'm going to go ahead and disconnect that slider and run that into here. So I'm going to say that in this case, we're only going to have a positive rotation. So I'm going to change my rotation angle from negative 90 to 0 and to positive 90. And hit OK. And I'm going to go ahead and set that for actually, say, 45 for right now. If I run that into the T, it'll say that my potential domain is 0 to 45. This is my target domain. I don't want any rotations less than 0, and I don't want any of them greater than 45. And we can quickly change that. Now the sample is, what are our domains or our distances currently set for? What are our values currently set for? And again, we can sift through here and see, okay, 104 is the smallest one, but as soon as I move this point around, you're going to get a different set of values. To do that, we want to sort these and then isolate the top value, the smallest value, and the largest value. To sort them, just simply run them through a sort component. So go to Sets, List, Sort List, wire that into the K, and the resulting K is all the values in their order. Now, the lower limit is going to be the 0 index. So here what we're going to do is we're going to do a list item. Just give ourselves some space. So sets, list, list item. And the I is already set for 0. The index is set for 0. So when the list goes into there, that's going to give me a value of just the 108, the lower limit. To find the largest value, it's going to be the last one. So if we reverse the list so that the largest one goes to the top, we can go ahead and isolate it that way. So we're going to copy paste our list item, right-click, and reverse it. And now the largest number is on the top, so the largest is the 161. That will become the domain for our new sample size, or our source size, okay? So we're going to go to Math, Domain, Construct Domain. The lower limit is the A, which is coming from the first list item. The larger limit is the B, which is coming from our second list item. Now we have a domain that says 108 to 161. We'll go ahead and remap those. And now our rotation angles are somewhere between 0 and 45. So 0, 1, 5, 6, 13, 22, 34, and so on. That will become our angles for rotation. So we'll run those into the A for the angle of rotation like so. Okay? So now if you look, the ones on the very end are very flat, and the ones closer to the attractor object have a little bit more movement to them, and we can control it even more, like so. So now this one, which is the furthest away, has the most movement. Now these are in different planes. Let's go ahead and just move this point, this attractor point. vertically to be at the end. Let me show this object real quick. There we go. I'm going to go ahead and move this vertically to be at the same plane, like so. There, now they're on the same plane. Again, we're going to hide this. And as I move this attractor object in, you'll see that those fins that are in the middle have the lowest rotation angle because they're the closest, and the ones furthest away have the largest. If I want to reverse that, so the ones that are closer have the largest, all you have to do is swap the order of the domain. Set the larger value into the A and the smaller value into the B, so those that are closer have a larger rotation, and those that are further away have a smaller rotation. That's it. Now we just go ahead and group all this stuff. So this is all about creating the domain, okay? And now we can go ahead and save this file. This is about a rotation angle, like so. And now we have a scale factor as well. So wider, thinner, so on and so on. Turn off some of this old stuff. And as I create more or less points, or more or less gills, you'll start to see that effect even more. So you'll see it has more rotation towards the middle and almost becomes flat towards the end. If I set my actual scale factor just to be 1 so that that doesn't throw off the perspective, you can really see what's happening like so. All right, go ahead and save that file, and we'll go ahead and pick up with applying this to several faces to create the Herzog and de Meuron signal box exercise.